Hey, so right now you know the reason why we need to design, why we need to have an infinite open loop gain. It's because we want by just using resistors and we can control the closed loop gain. Okay, and for this simple configuration, this is op-amp. This is operational amplifier, and then we just use a feedback, right? We connect the output to the inverting terminal. So this is a feedback. So following the definition of the amplifier, the output voltage equals AOL times VB minus VA. And VB is VI, VA is VO. Okay. And so rearrange this equation a little bit. We have VO divided by VI equals AOL. This is 1 minus, wait. VO, this is 1 plus VO. Okay, this is right. Okay. VO divided by VI is AOL divided by 1 plus AOL. And when the open loop gain is very large, and we have VO divided by VI is 1, which means VO equals VI. And because VO connect to VA and VA connect to VB, so we know VA equals VB. So that's why when you connect a negative feedback to the input, you will have VA equals VB. So this is the golden rule. Okay, we use this very simple configuration to explain why you need VA equals VB. And for this, we call this buffer. We call this configuration the buffer op-amp. Buffer means yes, it has VO equals VI. The voltage doesn't change at all. But because this op-amp has a very large internal impedance, very large input impedance, so there's no current flowing into this structure. So IA equals IB equals 0. In real case, it will be very small. And output will be always VO. So no matter what kind of load it connects, the output voltage will be always VO. So it has a buffer, so it can prevent the previous circuit affects the output. Okay, so 像这个就是一个很简单的回授，我们把输出连回到我们的这个反向端，我们说这是 inverting terminal， 连到负极这一端。那推导一下，你会发现，当它的开路增益 AOL 非常大的时候，那它的整个增益呢，闭路增益变成是1，所以你得到 VO 等于 VI。那 VO 连到 VA，VI 连到 VB， 你就得到 VA 等于 VB。这就是为什么你有一个负的回授进来的时候，这两端的电位差会相等。那这个 configuration， 这个 structure 我们说它是 buffer 结构，它虽然没有放大电压，但是它对前面这个电路跟后面这个电路做一个隔绝，因为你没有首先这个运算放大器。它的输入阻抗很大，所以它的输入电压几乎为0，而且它的输出阻抗为0，所以你不管接任何电路，它的这个 output 永远是 VO， 就是你不会上一个的电路不会影响到下一个电路，所以我们就是把它作为一个 buffer。OK， 虽然它没有任何放大的功能。OK，so this explains some people's question yesterday. Okay, so please copy that, or you can take a photo is copy. Take a picture. Okay, so we explained why you need a very large open loop gain, and why if there's a feedback, you will have this golden rule, VA equals VB. Okay, and why there are two input? Because one major function of the operational amplifier is to amplify the voltage difference, and because for thermocouple, its output it has true voltage, and we need to compare the difference of those two output. So that's why it is designed like this way. Okay, so it amplifies the difference of two voltages. Okay. 好，那为什么它是设计两个 input？ 因为像我们热电阻呢，thermocouple， 我们的热电偶它的输出会有两个电压，那我们需要去比对这个两个电压的差值，然后再换算成我们的温度，所以运算放大器它很多的 sensor 它都是输出是两个电压，我们去放大它两个电压之间的电位差。Okay, so it is designed this way. So does anyone need more time to write it down? Okay, please take a photo because I'm going to lower the screen. And one more thing before we move on, because this is the internal configuration of an operational amplifier. It has several transistors. This is called transistors, and capacitors and resistors. So it's very complex. So this is non-inverting terminal. This is the inverting terminal. This is the output. So we won't look into this. So that's why we only talk about here. We only talk about its equivalent circuit. So its equivalent circuit is this equivalent circuit. It has two inputs, V1 and V2, and because it has a very large input impedance, so this is an open circuit because the resistor between this is very large. And its output is AOL, its open loop gain, times the difference between V1 and V2. And this is the output. And there's no output impedance, so it's just a wire. There's no resistance there. Okay, so that's the equivalent circuit for the previous complex circuit that I just showed. 好，那有同学问为什么是这样？那这个是一个等效电路，它实际的电路就是上一张照片里面的，很复杂。但是它故意设计成有两个输入，而且输入阻抗要无限大。那它的输入增益，它的 open loop gain 开路增益是无限大，乘上呢这两个输入的电压差，形成它的输出。Okay, it's intentionally designed this way. Okay, so and saturation, because in the real case we need to power the operational amplifier, and the output voltage cannot exceed the power. So it's quite reasonable because the energy is this. You cannot generate more energy, right? So the most voltage it can output is just the power you give it. Okay, so this is so we introduced inverting amplifier we can calculate its closed loop gain by using golden rule. Okay, but if this VO is larger than VCC or smaller than minus VCC, it remains in VCC, and the value, the output voltage remains at minus VCC. So this is the saturation. We call this saturation. It's here, saturation, 饱和. Okay, and so inverting amplifier, so the OP, the operational amplifier, always works in the feedback configuration. We always use feedback. And if we connect the voltage to the inverting terminal, the output gain will be a minus. The output gain will be minus RF divided by RI. So we call it inverting amplifier. And if we connect the input voltage to positive terminal, so we call this positive terminal a non-inverting terminal, and its closed loop gain is just we calculated yesterday, right? It's 1 plus RF divided by RI, if I'm right. If I remember, its closed loop gain is 1 plus RF over RI. So that's what we talked about yesterday. Let's see, where is it? Okay, and then so we keep looking. Yeah, 1 plus R plus Ri. So yeah, so we just introduced this. When RF is infinite, how means RF is infinite? I is here. Okay. Anyway, in this structure, this is called buffer or voltage follower. It reduces the impact of the previous amplifier on the next one. So we may have an input circuit here. We may have an output circuit here. So it can prevent the previous circuit affects the next circuit. So we use this buffer as an isolation. 就是我们用这个 buffer 来做一个主角哦。Okay, so next we are introducing summing amplifier because as we mentioned previously, the operational amplifier can not only be used as an amplifier to enlarge the input voltage, but it can also be used to do arithmetic operation. So summation. So how can we do for the summation? The same thing, we apply golden rule. So we know since we connect one end to the ground, so we know VA, the voltage at point A is 0, right? And then since we know the voltage at A is 0, if we are given V1, V2, and V3, and we are given R1, R2, and R3, and the voltage here is 0, we can calculate I1, I2, and I3, right? And then so if this is VO minus 0, the voltage here is 0, divided by RF is I4. So we assume there's a current coming in, we assume there's current coming to A. So the summation of the current coming to a node is 0, so then we apply KCL. So in this case, we apply Ohm's law and we apply KCL, and then we can find out the relationship between VO and V1, V2, and V3. So that's the logic behind it. So I'm going to derive the final equation really quick. So from golden rule, we know VA equals 0, and then so we have I1 plus I2 plus I3 plus I4 equals 0. So we have this is V1 minus 0 divided by R1, V2 divided by 0 divided by R2 plus V3 minus 0 divided by R3 plus I4 is VO minus 0 divided by RF equals 0. So, VO equals minus, this is RF divided by R1 times V1 plus RF divided by R2 times V2 plus RF divided by R3 times V3. Okay, so this is quite simple. So if we want to just add V1, V2, and V3 together, we could choose RF equals R1. We could choose, if we want to develop a circuit which is V equals V1 plus V2 plus V3. Okay, if we want to do it this way, how can we do? We can choose R1 equals R2 equals R3 equals RF, right? If we choose the resistor, we make resistors all the same, but we have this. But if we make resistor all the same, we will have this. We will have a minus, right? Minus V1 plus V2 plus V3. So let me ask you a question. How can we, but in the end we want this. We want this V1 plus V2 plus V3. So how can we get this? How can we get rid of the minus? No. And anyone know how? Okay. If you remember for the inverting amplifier. For the inverting amplifier, we can enlarge VI, but we will have a minus sign. So if you want to get rid of minus sign, we just add an inverting amplifier at VO. So let me erase this. We can add this. This is minus, plus. This is ground. This is RF, maybe RF2. This is R, I, R, maybe R4. Okay, and then this is VO1. So we have, so if we make, so I write it here. So this is an inverting amplifier. So inverting amplifier is AV equals minus RF2 divided by R4. So if we make R1 equals R2 equals R3 equals RF, and we make R4 equals RF2, we can have VO equals V1 plus V2 plus V3. Okay, so by putting two amplifiers together in series, we can perform the these arithmetic operations we want. So that's how we do it. Okay, just one simple example. So nothing special. I apply golden rule to solve the relationship here, and I kind of memorize this is a non-inverting amplifier, so I can draw the circuit. 好，那如果说我们乘刚刚的那推导出来之后，如果我们要将三个电压讯号相加的话怎么办？那我们就是选 R1 等于 R2 等于 R3 等于 RF， 此时会得到这个，因为它也是接到反向端。那怎么把消除掉这个反向呢？那我们就是我们的方法在它的输出再接上一个反向放大器，然后把这两个电阻选一样。那这样的话，你就会消除你的反向，就是负得正，它要变正向，然后得到我们的这个数值运算。这是类比运算 ，This is analog operation。OK， 这跟 digital 不太一样。digital operation you need to convert everything to binary， 转到二质化嘛，二质化再做相加进位。但这个就不用，这是analog operation. This is what people do calculation before digital computing. Okay, so this is an old technique, but it is fast because you see you just need two operational amplifier, and you don't need to do anything. You just need to pick these values of this resistance. Okay, so if your calculation is fixed, you can do this quickly and efficiently. Okay, so yeah, so any questions? 好，有没有问题 ？And okay. So if you have no questions, we're going to introduce the next type of amplifier. Okay. Let me see. Okay. The Does anyone need more time to write this down? Please raise your hand. Okay, if no, just keep introducing more. Okay, this configuration is called the difference amplifier. So it's a little bit complex. So right now, because we want to subtract V2 from V1, and then so we put V1 to the inverting terminal, we connect V2 to the non-inverting terminal. And then we have R1 and R3. And we also have R4 here, is connected to the ground. And the feedback is RF. We always need a feedback. So how can we solve this? Because for golden rule, we know VA must equal to VB. Okay, VA equals VB, and there's no current for ideal op-amp. No current will flow here. No current will flow into this OP. So we have, if we look at this, if we look at node A, we have I1 equals I2. Okay, so start from node A. We start from node A, the same thing from golden rule. So golden rule. From golden rule we know because VA equals VB and IA is the current flowing into this op-amp. IA equals IB equals 0. And we have I1 equals I2. I1 equals I2. So how can we define I1? I1 is V1 minus VA divided by R1. Yeah, it's a little bit complex, but it should be okay. V1 minus VA divided by R1. I2 is VA minus VO divided by RF. VA minus VO divided by RF. Okay, and we kind of rearrange it a little bit. So we have what? We have VO divided by RF. VO divided by RF equals VA divided by RF plus VA divided by R1 minus V1 divided by R1. Okay, so, right? So we have VO equals 1 plus RF R1 VA minus RF R1 V1. So this is the first equation. Yeah, in the exam, you may be given values of the resistors. It will be easier for you. Okay, but right now you just know how it comes from.
我们先用 R1、R3、R4 还有 RF 来取代。那考试的时候，也许就是给你们数值，会比较好算。那你们在考试的时候呢，很有可能就是，告诉你 V1、V2， 告诉你这所有的值，让你算 VO 的值是多少。OK， 好，那这个叫做差分放大器 （difference amplifier）。Okay, and so this is the first equation, and then we look at node B because no current can goes into the operational amplifier, so we have I3 equals I4. Okay, so I need to raise this ring. Okay, we have here I3 equals I4. So we have, this is first. Second, I3 equals I4. What will happen? We have V2 minus VB. V2 minus VB divided by R3 equals VB minus 0 divided by R4. Okay, right? So, so we have this. We have V2. Okay, so we have VB. Okay, we have this R4 over VB plus VB over R3 equals V2 over R3. So we have R1, R3, R1 plus R3 times VB equals V2 over R3. So VB equals R1 plus R3, R1, V2. Okay, so this is the second equation. Okay, so by using KCL at A, we got first equation. KCL at B, we got second equation. And so the third equation is VA equals VB. So because VA equals VB, so we have VO equals 1 plus R1, RF R1, and then this is VA is VB. 这样有错吗？
为什么移项变拿完？
啊？
为什么移项是变拿完？
什么移项的时候变拿完
？I3等于I4的时候，左边左边你I3等于I4的时候，是左边的是
这里。
对，为什么它移项它变成R1了？
哦，我写错了，这是R4，这是R3跟R4，所以这是R4。OK， 好，等一下加分。R4，这是4，对，写错，这是4，这是4。OK， 好。R4， so this is R4. Okay, and then
this is V2 minus RF over R1 D1. Okay. Here it is a little bit tricky. This can be written as this is it can be written as 1 plus RF R1, 1 plus R3 R4 times V2 minus. Okay. So here we make this 1 over this is R4 R3 R4 plus R3. So make this. Okay, so the denominator becomes 1 plus R3 divided by R4 minus RF divided by R1. So right now if you are given all those values, you can calculate VO, right? It's a certain value of V2 minus certain value of V1. So in the exam, you already got the answer. Okay, if you are given all these values. But we need to keep deriving to see what happened. So if we keep decompose, so we can have, let me finish it, RF divided by R1 times R1 times RF. R1 times RF. This is but yeah, when you are given those values and you already finish calculation, but if we keep decompose, so because this is 1, RF divided by R1 times R1 divided by R, this is 1, so we intentionally add this, and we put R1 over RF, we multiply the numerator by R1 over RF. So it becomes R1 over RF, the second term becomes 1. So we have all this term, so we have RF divided by R1 on the beginning, this is RF, also RF divided by R1. So if R1 over RF equals R3 over R4, then VO is can be written as a very simple form, which is Rf divided by R1 times V2 minus V1. Okay, so that's a formula here, but please don't memorize this formula because I won't text you this formula.好，那考试的时候，如果给你们这个所有电阻的数值，其实你到前面都结束了哦。那这个是考试会考你的部分。那接下来就是继续推导，然后这一项是故意乘进去的，因为这一项这两个相乘刚好是1，但是我们希望把这个 Rf 除以 R1 提出来，所以前面没有 Rf 除以 R1， 是我们故意制造了一个 Rf 除以 R1， 然后我们把这个 R1 除以 Rf 乘到它的分子，然后会变成，所以这一项会变成这个东西。那如果这里分子等于分母的话呢，那你就可以把 Rf 除以 R1 提出来，然后很简单，就是 V2 减 V1。那前提是 R1 除 Rf 会等于 R3 除 R4。那如果 R1 除 Rf 等于 R3 除 R4 的话，那它的 output 电压就会等于一个 V2 减 V1 乘上一个倍率，然后这倍率就只有 Rf 除以 R1。OK， 好，所以so we can by designing the resistance, the value of resistors, we're able to make arithmetic calculations. Okay, so I won't text you here this, but at least you need to, if you are given these values, you need to write down the equation. Okay, so any questions? If no questions, you can take a break. Alright, so we will continue to talk about it later. 好，这就是如何用运算放大器做数值运算。我们教了减法运算，我们教了加法运算，其实都是用黄金法则，用 Golden Rule 来算。考试的时候不会那么复杂，考试的时候一定会把数值给你，那你就可以算出来了。所以这个是，对，我们不会搞那么复杂，但这个就是我们在设计的时候会用到的。
选项。
这一题从大家是开始讲的啊，希望我们希望我们的地轨争议是贝塔，是贝塔是对电阻值控制，对，然后它跟开路者的争议有关。对，那我们希望电阻值，电阻值来控制外的东西。所以你只要把这个变成无穷大，那就是跟这个争议有关，就可以调整它的整体。对，因为我们希望用简单的电阻搭配就可以改变它的放大倍率，我们就不用被这个开路争议绑死。它这是过程，对，然后一旦回收之后，就会得到别的这样你就会想，就是前提是你的开路争议是很大的时候。对 ，II 这个也是故意设计的，就 IAB 等于路易设计，然后你才会有 ACL，你才会把那个直接流过去，然后直接流从那流过去，然后你才得到。